Welcome to IB.
Alright, I'm back. So for today, we are going to represent the rational functions through an equation. So in mathematics, a rational function is a unique function which can be defined by a rational function. For example, fraction. So when we say fraction, it has numerator and denominator. For example, an algebraic fraction such that both the numerator and the denominator are polynomials. So it could be monomial, binomial, trinomial, or multinomial. So in this kind of function, the denominator should not be equal to 0. So let's review. If we have 1 all over 0, the answer is undefined. That's why in rational function, the denominator should not be equal to 0. If the numerator is 0, it is 0. So for example, we have the letter A. So first, let's have the denominator and equate it to 0 and get the value of x. So we have -1. So in this case, the x must not be equal to -1. Okay, let's check. F of -1 is equal to 2, -1 plus 1, 2 all over 0, or undefined. So it makes the rational function undefined. So x must not be equal to -1. Now let's move on to letter B. For letter B, our denominator is x minus 2, and let's equate it to 0. So the value of x will be +2. In this case, the x must not be equal to 2. Let's check. F of 2, 5 times 2 all over 2 minus 2. 2 minus 2. So this will be 10 all over 0, or undefined. So for letter B, the 2 makes the function undefined, or x is equal to makes the function undefined. So x must not be equal to 2. Let's move on. What about letter C? Let's get the denominator of C, which is x plus 1, and equate it to 0 and get the value of x, which is -1. So let's check. F of -1 is equal to 1 squared plus 2 times 1 plus 3 all over -1 plus 1. So this will become 1 plus 2 plus 3, -2 rather. This is -1. -1 plus 3, and this is -2 all over 0. So it is still -2 all over, +2, 1 minus 2 is equal to -1 plus 3 all over 0, 2 all over 0, or undefined. So on letter C, the x must not be equal to -1 so that the function will become a rational function. So hindi po kasama si -1 sa letter C, because it makes the function or the rational function undefined. Okay, now let's move on. At this moment, we are going to represent the rational functions through a table of values. So when we say table of values, it is a graphic organizer or chart that helps you determine 2 or more points that can be used to create your graph. So let's take the example number 1, which is 2x plus 1. So in this example, we are going to use 0, 1, 2, 3 as our x, as our domain. And for our range, or f of x or y, we are going to use the f of x is equal to 2x, 2 or over x plus 1. So let's have x is equal to 0. So f of 0 to 0 plus 1 is equal to 2. Now, what about 1? X is equal to 1, f of 1 to 1 plus 1 is equal to 2 over 2 or 1. Again, we are going to use f of x equal to x plus 1 because that is the given or that is the example. What about x is equal to 2? Let's proceed. X is equal to 2. F of 2, 2 plus 1 is equal to 2/3. 2/3. Now for the last x or for the last domain, the domain is 3. So f of 3 is equal to 2, 3 plus 1, which is 2/4 or 1/2. 1/2. So this will be our table of values. So our domain are 0, 1, 2, 3. And for our range or y will be 2, 1, 2/3 or 1/2. Okay, now we are going to represent the rational functions through a graph. So we have our coordinates. We have our x and y already. We have 0 and 2, 1 and 1, 2 and 2/3, 3 and 1/2. So if we are going to convert 2/3 into decimal, it will become 0.67, and for 1/2, it is 0.5. So let's proceed with the step 1. So we are going to create a Cartesian plane and graph the coordinates in the table. So we are going to graph. First is 0, 2. So 0, 2. Second one is 1 and 1. Next, 2 and 2/3. This will be here. And 3 and 1/2. And now, label the points and construct an imaginary line. So we are going to label the points. So this is 0 and 2, 1 and 1, and then 2 and 2 over 3, and then 3, 1/2, 3 and 1/2. Now we are going to create an imaginary line connecting the points. So there you go. This will be our graph. Now it's your turn. Would you mind to do this on your notebook and we will check it tomorrow. Goodbye.